Up till now, we've been practicing graphing equations of lines. And for the most part, our favorite form of the equation of line is that first one, the slope y-intercept form. It's called that because it has a slope and the y-intercept. Often we just call that the y equals mx plus b form because that's quick and easy. But it's called the slope-intercept form of the line. But there are other ways that we could describe the line as well. So we're going to look at a second one, the general form. And that's where you move everything over to one side, ax plus by plus c, where, and a little bit of changes here, okay, in general form there are no decimals and no fractions, so add that in. And the other rule in general form is whatever number's in front of the x has to be a positive whole number. Nick, where's your notes? Yeah, but where are your notes? Right in there. Okay? Yes, you're here. Awesome. And the third form of an equation of line is called a point-slope form. The point-slope form is when you know the slope and one point, and then you put that into the equation. So in this example here, if you were told that the slope was -4 and you had the point 5, 3, then you could label above this one x1 and y1, just like we label in our distance formula, our midpoint formula, or slope formula. But since we only have one point, we just have to label one point. And then you just plug things into the point-slope formula as is. So you plug your slope in and plug your 1 point. So each of these have their advantages and disadvantages. Okay? Slope-intercept form, huge advantages because you just look at it and you know the slope and the y-intercept right away. So that is a huge advantage of number 1. Number 3, if you know a slope and a point, you can write an equation instantaneously, which is a huge advantage. Because often you know the slope of a line and a single point, not necessarily the y-intercept. If you then take this equation, can you see in this equation that if I wanted to, I could distribute the -4? And if I wanted to, I could add 3 to both sides. And from the point-slope equation, you could change it to y equals mx plus b form, or the slope-intercept form. And then you would know, oh, now I know my y-intercept is 23. So the point-slope form is a nice way to start your equation and then to rearrange it. The general form is probably the least helpful of all the forms because it doesn't tell you any information right away. But since there's a general form of every single type of equation that exists, we also learn about the general form of a line. And so if I wanted to, I could rearrange this to get y by itself. But right now, the general form isn't very helpful. One of the things that you're asked to do is to take one form of the equation and write it in another form of the equation. So the thing you need to memorize about the general form. The general form has no fractions, no decimals. And the general form, whatever's in front of the x has to be positive. We make one side equal to 0. So when looking at my first equation, do we have any fractions or decimals? No, so we're really close. I look at the value in front of my x. Can you see that 3x is already positive? So if I'm going to make one side equal to 0, I'm going to make the left side equal to 0 by subtracting y on both sides. I would then get 0 equals 3x minus y plus 4. And general form, they generally write the 0 on the other side, so it doesn't matter. You could just rewrite it with the 0 on the right-hand side, and we've got the general form. So if all the numbers are integers to begin with, positive and negative whole numbers, changing to general form is relatively easy. But in the situation like in part B, we have a fraction. We start off with y equals 1/2 x minus 3. How would you get rid of a fraction? Double it. If we doubled that, if we multiplied by 2, we would get rid of the fraction. So again, we have to think a little bit about what happens with equations. The main rule for anything you do with an equation is what you do to one side, you do to the other side. Maybe in grade 9 or grade 8, did they ever do like balance beam things where the two sides of the equation are balanced? So if you double the right side, you'd have to double the left side. Well, what does that mean with an equation with more than one thing? Doubling the left side, that's going to be easy. I can just multiply y by 2, right? Doubling the right side means this whole side is going to get doubled. Okay? I'm going to do a preliminary step, which most people skip after they've done enough of these. Okay? The preliminary step is I'm going to put this whole thing in brackets and say I'm going to multiply by 2. I'm going to rewrite the green again and show what most people do as a result. Okay? So that first step, you can write it in your notes right now. Most people don't show that first step, but that first step is important for understanding what normally you see when you double both sides. Okay? And it might help you understand why you do that. Okay? So if I want to multiply by 2, you might have said, oh, someone just told me multiply everything by 2. Well, why do we multiply everything by 2? Because when I double the whole side, it gets distributed, right? So if you see that, this step where you multiply everything by 2 makes sense. And now that I've multiplied everything by 2, I will get 2y. Here, the 2's simplify. We just get x, and minus 3 times 2 is minus 6. So now we've gotten rid of our fractions and decimals. We need to make one side equal to 0, and we need whatever value in front of a positive. So how do we do that? Well, we subtract 2y on both sides. 0 equals x minus 2y minus 6. And we have general form. Yes? I'll be fine with that. I'm just technically in general form, the 0 is on the right. Now, one of the reasons for a general form with rules like this is so that you can ask a question and everybody can rearrange it to get the right answer. So when they're making a textbook, they can say, this is what your answer should look like, and this is the only way your answer should look like. And so that's why the rules of the positive value in front of a are there. That's why the rules of no fractions. Okay? Technically, there's other rules that this needs to be in simplest form. Because what would happen if I multiplied everything here by 2? I'd get 2x minus 4y minus 12 equals 0. Well, that still follows all of the rules, but it wouldn't be the general simplest form. And so a lot of mathematics has got a simplest form so that everybody can be in agreement what the right answer is. So if you were working with somebody else and say, I got this, and they said, oh no, I got this. Well, then you might both be right, but if we have an agreement what simplest form is, then be like, oh, okay, right? You're having an argument. The answer is a half. No, I got 3/6. No, I got a half. No, I got 3 out of 6. You go back and forth. And it's like, that's the same thing. But if we have a simplest form, then everybody can be in agreement of what it should be. So now we have the general equation, and we want to change it to y equals mx plus b. So if our goal is to get y equals mx plus b, what we're really trying to do is get y all by itself on one side of the equation. If we do that, whatever's in front of the x will be m, and whatever number is by itself will be the y-intercept. So if I want to get the y all by itself, okay, in this equation here, I could move the 4x over and the 6 over on both sides. Again, what you do to one side of the equation, you have to do to the other side of the equation. What would I be left with on the left-hand side? Negative 3y. For whatever reason, sometimes when you move everything away, people just just get rid of the negative. That negative is still in front of that 3y. It stays in front of that 3y. So then I would have negative 4x plus 6. How do you get rid of the negative 3? Divide by negative 3. And again, this whole side gets divided by negative 3. This whole side gets divided by negative 3. And when the whole side gets divided by negative 3, each individual term would get divided by negative 3. Now, writing our final answer, when I have negative 4x over a negative 3, well, a negative divided by negative is positive. You write the number by itself, so 4 divided by 3, x. 6 divided by 3, negative 3 is negative 2. So now we've changed it to y equals mx plus b form, and we would know the slope is 4/3 and the y-intercept is negative 2. That's where it was. This is what I wanted to do. Just going to move that over to the side for now. I'm going to draw a line here. Just because you have y equals mx plus b doesn't matter if you got the y by itself on the left or on the right. Just like before with the 0, it didn't really matter if you got it 0 equals or blah, blah, blah equals 0. So sometimes, and I just want to show you this, you might decide, I think it's going to be a little bit less work for me. Instead of moving all of the x's and the numbers to the right side, what happens if I just move the y to the right side? So I could just add 3y and add 3y. What would that give me? That would give me 4x minus 6 equals 3y. I could now divide everything by 3, and I'd get 4 over 3x minus 2 equals y. Notice it's the same answer, just the y's on the other side. Okay? Generally, though, we would then look at this and say it's asking for y equals mx plus b form. You will, just because you like saying y equals mx plus b, you don't like saying mx plus b equals y, you will probably want to rewrite it with the y on the left side because it just feels more natural. But it's exactly the same answer both ways. So I'd like you to take b and rearrange it and see how you do. All right, we'll check how you did. In this case, in particular, I would add 2y to both sides. You make less mistakes when you deal with positive numbers than when you deal with negative numbers. It's not wrong if you moved everything over the other way. Now, dividing everything by 2, And you could either leave it as a fraction 9/2 or change it to a decimal 4.5. Both would be fine. That homework is out of your textbook, so it also, I know we've been doing everything out of worksheets in this unit, but your textbook also has a number of good questions in this unit. So if you're ever looking for more practice or some more examples to look at, you can go through your textbook and see that as well.